Assalamualaikum warahmatullahi wabarakatuh. Now we are in chapter 4. So for chapter 4, we are going to learn how to get the best reactor at certain operating condition. Okay. So firstly, what we are going to revise is regarding how to get the conversion in any reaction. Okay, this is the formula for conversion where X we know as a conversion in any process. So the formula is mole of A reacted over moles of A fed. Okay, so if we have 400 moles of A reacted, and then we have total number of mole for A equal to 1000. This is the feed. Okay, so we will get 0.4 here. So X equals 0.4. This can also be expressed as this formula. Okay, where Ni naught is the initial mole. Okay, mole at after certain time. Okay, Ni at time I. This is the initial mole as well. Okay, and then how we get this one? Okay, so we know that we have learned previously regarding molarity or molar concentration. So we know that the formula for concentration or molar concentration or molarity is C equals what? N over V, right? So N, if we rearrange this, we will get Cv. Okay, how to get this term? Okay, Ni over Ni is 1, and then left with Ni over Ni naught. So if we expand this one, we will get Ni naught over Ni naught minus Ni over Ni naught. So this one become 1. 1 minus Ni over Ni naught. So Ni is here, where we can express this. We can use this Ni equals Civ. And then for Ni naught, we can express as Ca naught times with V naught. Naught means initial value. So this is the initial concentration, this is the initial volume. So here Ni, okay, Ni, we can take this one, okay, that's why it becomes this. For Ni naught, we can take this one, replace or substitute, we will get this. That's why we can get this expression. In the previous lesson, we have also discussed about this formula. Okay, how to get this formula. This is the initial mole. So if we expand, we will get Na naught minus Na naught times X. Okay, we will get the remaining number of mole. Okay, after we minus the conversion. So we will get this, and then this is after we factorize this, and then we have also derived this formula as well for batch reactor. Okay, so you can look at the previous lesson how to derive this one. And then this is for flow reactor. Okay, previously we have learned about batch reactor where we use term N. Okay, N A equals Na naught 1 minus X. Okay, but for flow reactor, since we need to consider time, so time we need to divide this with time. Okay, time divide with time. That's why we get Fa equals Na over T. Right. Okay, that's why we can replace this term with Fa. T means time. This is mole, so the unit will be mole per, let's say, per second. Okay, for back, this is for flow reactor. Okay, need to have time. But for batch NA, we only have moles as the unit. Okay, so no time here. That's why here we can use FA equals FA naught, and then this one will remain the same. Okay, and then why can we from this we can get this formula. Okay, let's see the formula of concentration. Just now we have agreed that the formula of concentration, molar concentration or molarity, is Na n over volume. Okay, so here if we make it as flow reactor, this is for batch reactor, right? If we turn it into flow reactor, which means this will become flow rate, right? Molar flow rate, and then this will become volumetric flow rate. So what we will have here is C equals N over T over V over T. And then here, if we solve this one, we will get N over T divide with V over T, we will get N over T times with T over N. Okay, and then this one we can cancel it. Then we still get N over V, right? That's why we can use FA equals FA naught. We can turn it into CA equals CA naught. Okay. Then last but not least for this for flow reactor, previously we have derived the mole balance or the formula for CSTR. Okay, where we have V equals FA naught minus FA over negative RA. Sorry, negative RA. So from this, what we can do is we have this term, right? Here we have this term. We can substitute inside this formula. What we will get is FA naught minus FA naught 1 minus X over negative RA. So we expand this one. What we will get here is V equals FA naught minus FA. Sorry, this is FA naught here. Okay, FA naught. Okay, so FA naught. Expand this one, FA naught. FA naught times with 1 we get FA naught, and then FA naught times with X we get minus FA naught X. Then bear in mind we have this bracket, then we need to open the bracket. We will get FA naught minus FA naught, cancel, right? Then negative times with negative we will get positive. That's why we get FA naught X over negative RA for CSCR. That means for CSCR, either we can use this formula, this formula, or this formula. Okay, previously for PFR, we have learned about this formula. You can always refer back to the previous lecture, yeah, to get more, to get clear picture regarding this topic. Okay, and then after we integrate, we get this formula. Okay, over RA. Okay, this is from previous lecture, but for PFR we can also have this kind of relationship. Okay, okay, the same concept. We can integrate this. Okay, integrate both sides, and then we can get this as the final formula after we integrate this. Okay, so how to do this? we can bring V to one side, where if we rearrange this formula, it means we integrate both sides. Integrate both sides. Okay. So what we will get is, here we will have integration of 0 to V for volume. Okay. In here we will get F A naught. Okay, we bring negative RA to this side, right? So bring to this side, what we will get is integration of 0 to x. Okay, integration of 0 to x dx over negative RA. Okay, this is if we have a conversion as our information in the question. So we can use this formula. If we have the information of the flow rate, we can use this formula. So you can use either one to solve a V for PFR. And then for PBR, you just need to replace V with W. Here we have W equals F naught 0 to x dx over negative RA.